Thank you. Okay. Hi everyone. Good morning. So first, I need to appreciate we have a chance to share something with you because of the HITB conference. So we did appreciate it first. And our topic today is about how to exploit the blockchain, the public chain, and the smart contract vulnerabilities. So my name is Jiafeng, and my colleague is Changcheng. So about our personal bios, you can visit the HITB conference website. So there, I don't need to introduce it. So this is about our team, the Red team. Our Red team is belong to the 360 Complaint Information Security Department, and our research and knowledge includes security servers and Red Blue confrontation and fake penetration and blockchain security something. And if you are interested in our team or company, you can contact us. As every page have an email, so you can contact us. And this is my Twitter's name. You can follow us. Okay. Talk about the blockchain, and this is today's presentation overview. First, we need an introduction and background. So, if you have know about what is the blockchain, so just be patient, because I think there is someone don't know what is the blockchain and something. So the next part is the public chain, and the first part is a smart contract. Last is concluding. So let's begin. First, introduction and background. So first, we need to know what is the blockchain and has defined or concept. Okay, yes, a blockchain is an intelligence peer-to-peer network, or blah blah blah. So, after I read this sentence, I have the same question: what the fuck is the blockchain? So we need to figure out. This is not important. So this is our architecture. This is very important. So they have 3 layers. In the bottom layer is a peer-to-peer network, and they have a load type and a message. So we need to connect every node because the blockchain is a decentralization. So we need to connect all of these nodes. So this is peer-to-peer network need to do. This like the TCP stacks transfer layer or something. And the middle layer is the blockchain and the consensus and POW, the proof of work or meeting or block structure or something. So this is the key. And the top layer is the application layer. It's about the wallet or the meeting pool or something. This is application, or we call it as the decentralization application, DApps. So we need to figure out more information. So this is a blockchain's core technology about the P2P and smart contract and cryptography and consensus. So blockchain is not a new technology, but the technically combined of the old technologies. Its key technology including this, and other technology are all older technology with more than a decade of history. And for example, we can research something. For example, the P2P. If you are using some download tools, for example, you need to download some file from the American the server to download some files. If you are using some download tools, usually he will using the P2P dynamic network. So if you want to download some file and download it in your computer, and he will share with someone, and the other one want to download the same file, he won't download from the American and just download from your server or your laptop. So this is the P2P. Some of the download tools will start two threads. One of them is to download, and one of them is to just share your file. So this is technology. And each pair from the peer-to-peer network is equal to other pairs. So there are no privileged pair. And there is no central administrator device or in the center of the network. So this is a core technology. And other smart contract and ours. So blockchain features. So if you are a hacker, you must be focused on the alarmers. So this is very useful. And D2T2 ever introduced it. And blockchain generations. So talking about the blockchain, I usually will compare it to the internet. So in the development of the internet, one can point to a landmark event then can be used to divide the process into stages. So, for example, the 1970s, where first wide welcome to the network has been cracked, and the development of the electric mail system in the 1970s, and the creation of the Ethernet in the decide the launch of the World Wide Web in the 1990s. So I will to compare it. And in similar ways, it's possible to look back the development of blockchain and also divide into different stages. So it's like this. I think we have just now we have a four stage. The first stage is zero. It's generation 0. It's a blockchain appearance. And the generation 1 is Bitcoin and derived currencies. It's like a lot of the Bitcoin. And generation 2, most of the people think about the it's because the smart contract is just has been cracked. It's like the Ethereum is so Ethereum have the smart contract. So a lot of people using the Ethereum to build something or to use something. And three are about the future. So some of them believe the EOS is a representative to the generation 3. I don't think so. I think the generation 3 is about the future. I think if we are in this generation 3, the world has been changed because, for example, we can using this technology in the IoT or something. So this is generation 3. And this is about some background or instruction. And this is about security status, the blockchain. This is some of the cryptocurrency in recent months. The Bitcoin recently has been falling. Yeah. This is appearance price of the various digital currency such as the Bitcoin, is fall and rest. After deep investigation, it's found that there is a hacking behind it. So there is I think there is no absolutely security system in this world because, the empty gox and the Bitcoin and the Ethereum and the US, all of this has been hacked. So I think there is no absolute security. And this is a trade. This is trade in economic loss caused by security incidents. So you can see that it's just its rise. And in the 2014s, we have an event we named is Metgox. The Metgox exchange currency has been hacked. And the 2018s is just this static is just until half of the year. The 2018. So in the 2018, just half of the year, we have lost 220 billions. That's a horrible date. The unit is 10,000 US dollar. And this is same. And this 2018, just half of the year, we have more than 15 events. Okay, this is horrible data. And according to our research, all of this we have make this. So there is a 33% third tag is input and output verification. For example, the buffer overflow and the cross-site scripting. The buffer overflow is happening the public chain or the exchange currency, and the cross-site just the exchange currency and the injector tag. For example, the core injector or the circle inject. And next is a code quality problem. I think if someone to code some program, there must have some problem. So you need to tag it or to hacking it or penetration test. And the third part is safety features about the override access and unsafe random numbers. Talk about the random numbers. So if you are play the coins or to buy some coins, you must know the formal 3D. So recently the formal 3D has been attacked because of random number. He has a function is airdrop. So airdrop some coins. So he has using the time step to using the as a random phrase. So there is a problem. We can control his time step to attack it. So if you are interested, you can search it. So this is about the introduction and background. So let's take about the vulnerabilities. So we are into today's theme and the public chain and the smart contract. Our research is more than this. It's not just the Ethereum and US. We research the trend and XRP or something, and consumer chain like the Hyperledger and Fabric and CA8. So maybe this time just the public chain. Maybe next time Amsterdam we will share the consortium chain. So focus on this. Ethereum is a decentralization platform and then run smart contract, and the US is just for the decentralized application. So this is different focus. The Ethereum focus on the smart contract, and the EOS is focused on the decentralization applications. And first, we need to figure out the US law. Sorry, as Ethereum. And first is a background. We need to know what is a GS. So what is the GS? Because our vulnerability is happening there. So what is the GS? You can download it from this GitHub. So it's a project. So after you download it, just make it. You can get it. His full name is Golang Ethereum. So it's an Ethereum client code by Golang. So this is a GS. So in the right, this figure is a website. You can know that it's a Ethereum's Explorer. According to the Ether nodes, this is Ether nodes. According to the Ether nodes, the GS can run the two threads here. So given GS is a majority in the Ethereum network. So adding critical vulnerabilities, it could possibly cause several damage into enter the Ethereum system. So we will to research it. And the core of the Ethereum, all client implementation should follow the same protocol. Because you want to using all of these nodes to do the same thing, you need to follow the same protocol. For many consensus. So those protocols include the RLPX and DVP2P or something, the sub-protocols, like the Ethereum WAL or Ethereum WAL protocol or the LES. LES is a light Ethereum protocol. So this is some introduction, and ILP, this is about the encrypt hardshake, and the education. and pair persistence and UDP node discover. So if you are sometimes we want to build a private network, so we will start the JIS with arguments is node discover. So in this situation, we will not open the UDP node. And the DVP2P is support attribute sub protocols and connection management. So we are focused on what? Focus on the LES. This is figure this problem. If we want to open to build a network and using the LES, we just with this argument JIS and light server. And this is a number. This number is a network number. If you want to connect the network, you must be using this network ID. So this must be the same. So while an LES client requests block header from the an LES server, the get block header message is sent from the client, and the message handler on the server side passes the message. So, okay, this slab shows the code slab of the JIS implementation of the get block header's message header. So this is vulnerability code, and you can find it in the LES folder and the handler.go source file, and in the and start from the line 455 the low reverse case in the handle by the LES server. In the line 457, the LES server check if there is still block header available after skipping the query point the skip block. If the check passed, the get block hashes from hash is called in the line 458. And an array of block header is returned. We just need to focus on an array will returned. And here, this is a define of the get block hashes from hash. So you can see then the header return chain. This chain is an array. So it can be understood the block hashes from hash number of the query point skip at 1 is obtained. And then the query skip block hash is taken out from it. And this is about the query structure. And the header member is a skip. So the query point skip is using this. Its mark size is uint 16.4. So his mark size is this. It's FFFF. So an attacker can craft a malicious query with the query point skip. So it's FFFF. When query skip at 1, it's passed into the get block to pass it into the get block hash from hash. So an array will with a mark size equals 0 will be unlocked. So that's. Then by accessing the to the 0 size array with the index query point skip, the FFF, the LES server will crash and burned. So this process is like this. The attack using the get block header with the data. Data is the query point skip equals FFFF, and use this to pass the data into get block hashes from hash. And this function will to unlock an array. The array size is 0, so there will 2 index out of range. We have a demo to attack this. So first we need to make sure our no internet, and this is a public this is vulnerabilities. So we use it. This is a payload coded by Golang, and we will start load in left window. So we will start it and just with the argument net server. Just start loads, and in the right one, we need to check it. We need to figure out has G's rating. Under 1.810, this rating that will be attacked. So if we're using this payload, it will index out of range. And we test on the Ubuntu, it's the same. The same, just to start network. So if you're under this ring, you will be attacked. So we need to his IP address. So just enter his IP address and with the port. Okay, just type it. It will be indexed out of range. So that's easy. It will crash index out of range. Okay, that's easy. Okay, this is about the insurance attack. They will to do something. Okay, this is Israel. And next is about the EOS. The US being an operating system that should truly support commercial applications. And right is about the US price it's useless. One of the best things about using the WSM. So what's the WSM? It's a web assembly. So it's a useful tools. It's a US smart contract can be written in any program language then combines to WS file. So the EOS system just using the WASM file to build the smart contract. And just focus on the vulnerability. So this is problem happens here. This is file path, the libraries and chain and the WebAssembly and binary point CPP file and the line 978 the function has some problem. The table you can see here the table is the member function of the standard vector. So when you store some elements into a table, the offset file is not correctly checked. And you can see there is an assert. And there is an assert before setting the value, which will check the offset. But unfortunately, assert is only worked in the debug mode. So and it's does not work in the release edition. So it will happen in the main network. The offset file is read from the WS file in the data section. It's signed in the setting 2-bit value. So basically with vulnerability, we can write a fairly wide range after the table vector memory. So it's like that. So we can take control of the load. So we just take control of the loads. If the loads using some server, we can take over it. So by stealing the private key of the supernodes, so we just focus on the supernodes. So the US have some of the supernodes, and controlling of the content of the loop block. So we can control all of this EOS system. So if you wanna using, just take it. So process like this. First, the attacker uploads the mirrors contracts to the load OS server. And the two-step is to the server loads OS process parser the mirrors contract that which will trigger the vulnerability. And with the auto-bound writing primitive, we can overwrite the WSM his memory buffer or WSM model instance, and with the help of our malicious WSM code, we finally achieve arbitrary memory read and write in the load OS process, and bypass a common exploit mitigation technologies such as the DEP or something on 16.4-bit OS. So once successfully exploit, the exploit start a reverse shell. It can be reverse a shell and connect back to the attacker. So this is our demo. First we listen on our VPS or something. And this is start or load. This is a US system, a US client to start it. And the third window is XP just to attack it. You can fight it. We can reverse our shell. So we can get it. That's it. This is about EOS. So because of the time, we can share a lot of the vulnerabilities just one. And so next part is blockchain smart contract vulnerabilities about the reentrancy and the co-function builds or integrity overflow or DOS. Those. So we just want to share our research. So first, we need to know what a smart contract is. So people create smart contract every day, and the most used language is Solidity. So this is advice Ethereum, and very much like the JavaScript language. So if you are a programmer, it's just it's not difficult. So smart contract can are deployed on the node and running on the blockchain, and everyone can see a contract then was released on the blockchain. It's open source. And the biggest difference between it and the ordinary contract is real life is then it's not man-made. It's code-driven. So ruler defines the advanced to resolve trust relationships, and smart contract can run on our various public chains, such as Ethereum, EOS. So for this PowerPoint, we just focus on the Ethereum smart contract vulnerabilities. Okay, next is about gas. You just need to know in the Ethereum, every step to execute some code will lead to gas. This is a concept. No need to more. First vulnerability is about reentrancy. A reentrancy attack, probably the most famous Ethereum's vulnerabilities because the DAO. On the July 2016, the DAO smart contract was attacked. The hackers stole the 3.6 million Ethereum Ether. So which was about in their time is about 70 millions. So because this attack, Ethereum had a hard fork was divided into the ETH and the ECH. So you can find the Ethereum have the two coin. One of them is named the ETC, is Ethereum Classical. And the larger is Ethereum, is ETH. So this is because of this. So first, we have an example. It's coded by ourselves. This is a contract code with the reentrancy vulnerabilities. The full contract is then anyone can deposit some Ether and withdraw something, your coin or something. It's like a back. So we have a withdraw function, and you can so if the target address is a contract address, then by default remain the gas. You can see here. This is a problem that you call something, and and the address, they will to impute some address. If the target address is a contract address, then by default, the remain guess will be given to the target contract. And the fallback function of the target contract will be called. So the red part is a fallback function in the contract. Yes. If we have a contract like this, this is a fallback function. So if you are using the transfer something, using this contract, he will call this function by default. So we can construct our tag contract like this. This is our attack code. This is our tag contract. You can see that. So we have this function. This is a fallback function. It's a pollable. So we can construct an attack contract based on the characters of the transfer function. So when the for contract transfer to the attack contract, the fallback function is called by default. So I've said that. At the point, we can call withdraw function of the for with the for contract again in the fallback function of the attack contract. So it formed a loop, a loop. And the important thing is that after the transfer function attack, fallback function is executed directly. So the calculate of the balance is never performed. So it's formed a unrestricted loop. So it's like this. So we have a figure out this. So if you are account A is ordinary, we create a contract like a bank. We can deposit something and withdraw something. It's like the for contract. And ordinary account B. So you are account B, someone deposit some Ether to it. For example, the 15 Ether to it. And the third step is the attacker. The attacker will correct a contract. The contract, attack contract, correct and transfer 2 Ether to the contract and using the contract to deposit 2 Ether to the full contract. And the 5th step is withdraw 1 Ether to the attacker. And at the same time, the attack contract will directly call the fallback function. The fallback function will to call the full contract again. So it's a loop. That will withdraw all of this. All of the contract will be to the account C. So attacker can store all of this. So this is a process. Like this. We have a demo just to build it. If you are interested, you can download this video in the website. So first, we use an account to create ID mining contract and deposit some Ether. And next, we use another account to create attack. This is attack contract. This is Remax. It's ID. It's ID for the Ethereum smart contract. And we can set a victim. The address, it's a contract address. Okay, next is a star tag. Star tag is to using some Ether. This will depending. You can see he will use a lot of time because he's using a loop to get this. So with success. So we can see the hacker count is 97th Ether, and when we stop, it's 124 Ether. So the Ether is all out. That's it. This is about smart reentrancy. So if you want to research it, you can just search the DL. Okay, let's take a look the call function abuse. First, we introducing 3 call functions. First is a call function. The most used call function is then after the call, the variable's message point sender will be changed to caller A, and the execution environment is B. And the second is a delegate call function. After this call, a message point sender will be changed, but the execution environment will become A. It means directly call the code and executing in A. The third is a call code function. After this call, the variable message point sender will be changed to caller A. And the execution environment, the execution environment will be changed to contract A2. So this is a different call, delegate call and call code. So call function abuse, we have an example. So example 1 include we have we are using a 2 code function. One of them is a delegate call and another is a call code. So if the hacker construct attack load 2 using the 4 contracts delegate call function or call code function to call attack contract test function, because of these 2 function characters, the test function execution environment is in 4 contract. Just like the copy the code directly into the call contract. So the admin of the 4 contract will be changed to attack, can control all of this contract. And there is another example. Okay, look at the second example. In this code, the withdraw function only the contract owner and the contract itself can using it. So there is a contract owner and the contract itself can using this. Because of the require, you can say that there is S and the message sender, so you must be there. So attack contract attack used your call function and then call the withdraw function. So you are using the call function. So it's like, so for the withdraw function, it's the contract itself. So we can use it like this. We have researched, this is a CVE, and we found it. We look directly in the public function is this. The approve and call. It's approve and call, and you can see you can see here. It's a spender and point call. It can use. It's not limited. So the function receives some parameter and then directly use call function. So we can input some data to attack it. So like this. This is a real contract, but now it was too lot use because we will report it. You can see this is a contract. So about several hundred lines. So this is a radio demo, and the personal contract and the Cortex contract were to verify the vulnerability. So we use an account to create so we use the account to attack to create it, the problem contract. So we create it, just create it. And next we create personal contract. Now we want to construct a parameter to use a call function. So here we have a test. We're allowed to attack it just using our test, using some number to add some number. For example, in this situation, the edge parameter is in person contract is defined as turn. So this is contract defined, is turn. So if we call person contract once, just call once, it will be add 1, just increasing by 1. And this time we use this attack. It's just call once will be call 2. So you can see his age will be changed to 12. So in usually situation is 11, but we attack it will be changed to 12. So you can see that. So from the 13 has been changed to 15. So this is our attack. This is about the core function abuse. So this is one of them. So a larger core will be attacked. Okay, integral overflow. So integral overflow divided into the up overflow and down overflow. The overflow is a common in program. So in the Windows or something, it's always happen, the integral overflow. Okay, but in blockchain or the Bitcoin or something, this is very important because this is our money. So if there happen integral overflow, it's terrible. So let's take a 8-bit unsigned integer as an example. So you can see that the range of the unsigned 8-bit integer is 0 to 255, and which occupy 8 locations in memory. If 255 is increasing by 1, their entire concentration of it will be flipped to 0, and the original 8-bit integer 1 will become 0 due to a carry. So if it's 0 sub 1, the result 0 becomes 255. That's easy. Let's computer. So this is example. For example, suppose we first call our deposit function. Okay, that's deposit function. Depositing will deposit 5 Ether, and so our account balance on the contract is 5. Okay, we deposit 5, we have 5. Yeah. Now we call the withdraw function. Okay, we have to deposit 5, and now we call the withdraw function withdraw 6 Ether. In 0, it can be taken out because we have not 6 Ether, but because of the integral overflow vulnerabilities. So you can see that. That's the 5 sub 6. It's less for this, so we can take it out. So this is allow us to take it out. This is. So we have a research. This is a survey, we found it, and you can search the number and to download the source file. We look directly at the line 17 and the function distribute token. So the function distribute token. So now let's take a demo. The function resolved an array address and a lomotic. This is our address. It's an array, and another is a lomotic parameter. And then directly distribute the token to the address in an array. But there is no limited in the calculate or result is overflow. So very easy. We can use it. So this is radio. First, we create the main contract, and we have a 12 Ether balance. So first we need to compile it, and we to correct the contract, and we can using the balance of, we can see that we have the 12 Ether. So now we withdraw 12 Ether. Balance is 0. we have withdraw it. So this is 0. We have take it all. But you distribute it again, you will find this is a down overflow. This is happening in the real world, in the real main network. So that's easy. Okay, this is all vulnerabilities, and we have a concluding. So public chain attack, we have show you Ether and US node attack about the DOS or the take control over. This is it. And smart contract attack is about the retracing, co-function builds, the architecture make the overflow, and DOS and band randoms. So if you are interested in this, so the smart contract is not just this. So you can search them. There are a lot of the attack scales. So we have some adapt adjustment. So public chain, you want to adapt the public chain. I think you just have to figure out the program's execution process, because there are a lot of the code. So some of them is useless, and some of them is useful. So you need to figure out what is useful, and to figure out the program execution process. And for the smart contract editor, just be patiently, because the code is not too much. Usually, it just have several hundred lines to read it, and just view each of lab's code. And of this, thank you. So, if you are interested about this, you can communication with us. This is our email. And if you want to get more information or download this video, maybe you can visit the HITB conference. Thank you.
All right. Thank you for the talk.